Property of a light to change speed when travel from one medium to another, we call refraction. If it move from low density to high density, it slow down or move towards the normal or bend towards the normal. And if move from high density to low density, it will bend away from the normal. So example, you have a semicircular glass. So this is semicircular glass. The light strike the surface. Example, the light strike the surface. This one is air, glass. So imaginary line which is perpendicular to the surface, because this is a surface. So imaginary line which is perpendicular to the surface, we call that as normal. So this red line is a normal. And the one which strike the surface, that is called incident. What will happen when it moves from air to glass? The speed will increase or decrease? What will happen to the speed of the light when it enters from air to glass?
It will decrease.
The speed will decrease. The speed will
Yeah, it will
decrease or it will slow down. So when the speed decrease or it slow down, so what we observe? We observe it bend towards the normal. The angle between the incident and the normal is called angle of incidence. An angle between the normal and the refracted is known as angle of refraction. And there's one more thing which we can calculate. We can calculate refractive index. What is refractive index? Refractive index means ability of the medium to bend light. A tendency of a medium to bend light or ability of a medium to bend light, we call that as refractive index. How we can calculate the refractive index? The formula which we can use. The refractive index is denoted by a Greek alphabet. You can say N, but it's a Greek alphabet called eta. So refractive index denoted by eta or N, you can say. The formula is sine theta, you take in trigonometry. So sine angle I divided by sine angle R. And this formula is valid when it is traveling from low density to high density medium. So if I say that the angle of incidence was 40 and angle of refraction was 23, and the question is find refractive index, find N. So what is the formula to calculate the refractive index? Refractive index means ability of the medium to bend light. So how you can find the value of the N? So refractive index N is equals to sine angle I over sine angle R. So refractive index is equals to sine 40
1.64
divided by sine 23. What's the answer?
1.64.
1.64. So 1.64, but keep in mind refractive index does not have any unit. Why it is not having any unit? Because it is a ratio. Ratio does not have a unit. It's a ratio of the angle, like compared to air, it has 1.6 times greater tendency to bend the light. What is the meaning of this number 1.64? It means compared to air, it can bend the light 1.64 times. Is it clear? The concept of refractive index, the ability of the medium to bend light is called refractive index. Another example.
Sir, so the light is bent 1.64 times?
Yeah, the tendency of the material is 1.64 times higher to
Mhm.
bend the light as compared to air. That's the meaning of refractive index. Ability of the medium to bend light.
Okay.
Like compared to air, this material is having a tendency to bend light 1.64 times more or higher. So example, a light is there.
Okay.
It's in air and it moved from air to glass. This angle was say 20 degrees. Moving from air to glass, what will happen? Bend towards the normal or away from normal? Moving from air to glass. So moving from air to glass, it will bend towards the normal. So the angle will decrease. So example, this angle is 11. Now the question is calculate refractive index. Refractive index means ability of the medium to bend light. So if you want to calculate the refractive index, the tendency of a material to bend light. So formula when it is moving from air to glass. So refractive index N is equals to sine angle I. What is angle I here? The angle at which it
1.79.
hits. No, it's 20 degrees here. Angle
Yes,
of
sir.
incidence is the angle between the normal and the incident. So angle between the normal and the incident is 20 degrees here. So this will be sine 20 divided by sine the angle between the normal and the refracted. So this one is a normal and refracted. So angle between them is 11 degrees. So it will be sine 20 divided by sine 11. What is sine 20 divided by sine 11?
Yes, 1.79.
So 1.79.
So which angle do we need to find? Like we know n, we know what is n.
N is the refractive index, the ability of the medium to bend light. And
All right.
I, this is the angle of incidence. This one is angle of refraction. So this is coming out 1.79.
So we need to find how much the glass bends a light.
Yes, how much the glass is bending the light compared to air. So it's bending the light 1.7 times, 1.79 or 1.8, I can say 1.8 times. But it does not have unit because, like example, the term time is not having times. Like if I say 20 times, 30 times, 50 times, so it does not have unit. It is a ratio. So whenever light travel from air to glass, whenever light travel from air to glass, it will bend towards the normal. So we can find the refractive index of the material compared to that of air. But sometimes it is opposite. The light travel, instead of moving from low density to high density, it is opposite. So in that case, so imaginary line which is perpendicular to the surface, that's called a normal. When it moves or travel from air to glass, it will bend towards the normal. Sorry. So it will bend towards the normal, and moving from glass to air, it will bend away from the normal. Example, these angles are not given and the other angles are given. So moving from glass to air, this angle was given. For example, this angle was 8 and the other angle was given, say 25. And the question is calculate the refractive index. So if the light is moving from, because this one is air glass, and then air again. So when it is moving from high density to low density, so moving from high density to low density, then the formula is refractive index is equals to sine R over sine I. So the formula is reciprocal. If it is moving from low density to high density, it's sine I over sine R. But if it is moving from high density, like example, glass is having high density as compared to that of air, so the formula is N is equals to sine angle R over sine angle I. So refractive index in this case will be sine. What is the angle of refraction? It's 25 divided by angle of incidence is 8. So sine 25 divided by sine 8, what's the answer? Sine 25 divided by sine 8. What is the answer?
It's 3.03.
3.0.
Yeah.
So 3.03 or 3. So refractive index again for a medium or a glass is 3, means compared to the air, this glass was having a tendency to bend light 3 times. Because refractive index of air is 1, so we always get a refractive index of the material. So the two formulas for refractive index, depending on the question, if it is moving from, if in a question, a light travel from air to glass or water, then the formula for refractive index is equals to sine I over sine R. But if it is moving from glass or water to air, then the formula for refractive index is equals to sine R over sine I.
It's
So
upside down.
yes, depending on the formula, depending on the condition or the question. Then there is also another formula which is independent of the movement, whether it's from air to glass or glass to air. Then the third formula for refractive index is equals to speed of the light in air divided by speed of the light in a medium. Medium where it can be glass, it can be water. So this is a third formula. If speeds are given, then you will use this formula. Speed of light in air or vacuum is approximately same. So what is the speed of light in air or vacuum? What is the speed of light in vacuum or air?
330 or
No,
340.
330 is for sound, for light. 330 is for sound, but for light,
Light,
light is very super fast. The speed of light in air is approximately 3 into 10 power 8.
Yes, 10 for 8.
300,000 million 300 million meter per second, and speed of a light in a medium is v. So this is the third formula. If speeds are given, you will use this formula. Speeds are given, you will use this formula. If angles are given, you can use any one of them depending on whether, if it is moving from air to glass, you will use this first formula. If it's moving from glass to air, you will use second formula. And if speeds are given, you will use the third formula. So we'll solve some question now related to the refractive index. So example, this is a boundary of air to glass. The light which strikes the surface is called incident. Imaginary line which is perpendicular or 90 degree to the surface, this imaginary line is known as normal. As it moves from air to glass, so what we'll observe, it will bend towards the normal. The angles given, this angle is 40 and the second angle is 21. The question is, what is the refractive index of the glass? Part A. What is refractive index of the glass?
The answer is 1.8 or 1.79.
Yeah. Keep in mind, your calculator mod should be in degrees, because there are three ways you can substitute the angle. So the calculator mod should be degrees, not radian, because with radian you will get a different answer.
So I press shift mode and number 3 degrees.
Yes.
Okay, thank you.
So what we'll substitute, because it's moving from air to glass, so as it is traveling or moving from air to glass, so refractive index is equals to sine I divided by sine R. So in this case, refractive index is sine 40 divided by sine 21. So sine 40 divided by sine 21.
1.79.
0.79. So we'll write 1.79. Now, because it does not have any unit, it's a tendency of a medium to bend the light. 1.79, or you can round off to 1.8. If the second question was the speed of light in glass. So how you can find the speed of the light in a glass? You have the second formula for a refractive index. What's the formula? Refractive index is equals to speed of light in air, which is 3 into 10 to the power 8, divided by speed of a light in a medium, which is v. So what you need a v here, because that's a speed. The light was traveling with a speed of 3 into 10 to the power 8 meter per second in air. We need the speed. We need a speed of a light in a glass. And we already have refractive index. We have the refractive index 1.79. So we will substitute. Refractive index is 1.79 is equals to 3 into 10 to the power 8 divided by V. I need V, so we will move to the numerator and 1.79 in denominator. So V is equals to 3 exponent 8 or 3 into 10 to the power 8 divided by 1.79. What is the answer? 3 exponent 8 divided by 1.79. It will be in exponents. What's the final answer? 1.79 exponent. No, actually, exponent 9 cannot happen. Reason for that, you're dividing. If speed of a light in air is 3 exponent 8, how a speed of a light in a glass will be 1.7 exponent 9? In a glass, it should be smaller value.
It's 1.675.
Yeah, so 1.6 into 10 to the power minus 1, 2, 3. Sorry, not minus. This is 1, 2, 3, 4, 5,
7.
1.6 into 10 power 8. Meter per second. Because it was written 1 and how many 6? 1, 2, 3, 4, 5, 6, 7, 8. So it was written like this. And then, so I move the point 1, 2, 3, 4, 5, 6, 7, and 8. So 8 places I move the point. That's why it is 1.6 into 10 power 8 meter per second. Is it clear? And it is obvious that as the light travels from air to glass, the speed should decrease, not increase. Okay, it's up to you. You can take 1.8 or 1.79, but it will not make much difference to the answer. Is it clear? This example. Then another question. Example, light is traveling from water to air. So as it travels from water to air, it will bend away from the normal because water is high density, air is low density. And the angles are given. This angle is given 79 and the other angle is given 43. And A part is calculate refractive index. So refractive index is ability of the medium to bend light. Moving from, so keep in mind, don't substitute only the values. It is refractive index. It's denoted by N. So refractive index is denoted by N. That's equal to sine angle I. Sorry, sine angle R over sine angle I. Why? Because it's moving from high density to low density. And it will be sine 79 divided by sine 43. Sine 79 divided by sine 43. It is moving from high density to low density. Water is having high density.
1.439.
How much?
1.439.
So 1.439 or 1.43 I can say, or 1.43, 1.44 I can take. 1.44. That's a refractive index because it was moving from high density to low density. Is it 1.44 or 1.41? Okay. Then the second part, if I need speed of a light in water. So if I need speed of the light in water, the formula which relate the speed and the refractive index, the refractive index is equals to speed of a light in air or vacuum, which is 3 exponent 8, divided by speed of a light in water, which is v. The refractive index is 1.44 and this is 3 exponent 8 divided. So we need v. V is equals to 3 into 10 power 8 divided by 1.44. What's the final answer? So you can say 2 exponent 8. So this 2 into 2.08 exponent 8 or 2 exponent 8. That's
Sir, the answer is 200. I mean,
yes.
it's
So when you
20.
convert into exponent, when you will convert into exponent,
Yeah,
it
yeah,
will be 2 exponent 8.
yeah. Okay.
But, so you have because the number, whenever number is too big or too small, you should always express your answer in scientific form, like exponent of power of 10. Like if it is 0.00021, so it's better you express in scientific or exponent form. Same thing, if it's too big, then also represent in exponent. Is it clear, the concept of refractive index? So the ability of the medium to bend light is called refractive index. You can use 3 formulas to calculate refractive index. If it's moving from air to glass, that's sine I over sine R. If it's moved from
Sir,
glass to
but
air, yes,
if you give us the speed in the question, how will we know the refractive index? Like, how will we know the value of n? We will still need to find it.
then you will find, like example, if I mention the speed that it was moving, the light was traveling from say glass to air, the speed at this point was 2 exponent 8 meter per second. And as we know, approximate speed in air is 3 exponent 8. And the question is, calculate refractive index. So how you can calculate refractive index? So how you can calculate refractive index? What happened? In this case, the formula for refractive index is 3 exponent 8 divided by speed in a medium. What is the speed in a medium? That's 2 exponent 8. So refractive index is 3 exponent 8 divided by 2 exponent 8. So you will get 1.5. From
Yes,
the
got it.
speed, you can also calculate the refractive index.
Sir, can you please explain question number A?
The part A,
Yes.
look, in this question, the light is traveling from water to air. Water is having a high density, so it's a denser medium, and air is having a low density, so it's a rarer medium or low density medium. Whenever light travel from high density medium to low density medium, the formula for refractive index is the angle of refraction, means sine angle of refraction divided by sine angle of incidence. So with the angle at which the light strike, that is angle of incidence. Angle at which the light bend, that is called angle of refraction. So angle of refraction is 79, so that's why I put 79. Angle of incidence is 43, so I substitute 43. So sine 79 divided by sine 43, I'll get 1.44. Is it clear? Because in
Yes.
this case, it is moving from denser to rarer. But in the first example, it was moving from air to glass. So low density to high density, the formula is sine angle I over sine angle R. So the angle at which it strike the medium, that is angle of incidence. Angle at which it bend within the medium, that's called angle of refraction.
All right.
Then what we observe when light moves from denser to rarer medium, denser means high density, rarer means low density
Sir,
medium,
from dense to rare medium, the light speed increases or
increases,
decreases?
increases. Because light does not require a medium, So when less particles within the medium or there is a vacuum, light will travel faster. So when light moves from denser to rarer medium, we observe partial refraction and reflection. So what does it mean? Means some of the light is refracted and some of the light is reflected. We call that as partial reflection and refraction, or partial refraction or reflection. So example, a light is there in water. Example, you have a source of the light. So what happened? When the light strike, some of the light, imaginary light which is perpendicular to the surface, that's called a normal. So moving from water to air, the speed will increase or decrease? Moving from water to air, what happened to speed? So speed increases, so it will bend away from the normal. So when it bend away from the normal, what we call? We call this as a refracted ray. And the light which strike the surface, that light is called incident. And what happened? A small amount of light, not too much, but very small amount of light bounce back or reflected in the same medium. So if a small amount of light reflected in the same medium, so what we call, when both things are happening, reflection also occur and refraction also occur. Refraction occur when the speed changes, and reflection occur when it only changes the direction. So if I say this angle is 20 degrees, example, what will be this angle? Angle of reflection. More than 20, equal to 20, or less than 20? So it will be same, it will be equal to 20 because it's a reflection. But what about this angle? It will be more than 20. It can be any number, but it will be more than 20. So in this phenomena, what happened? When some of the light is reflected and some of the light is refracted, we call that as partial reflection and refraction of the light. Means both phenomena are happening, or both phenomena are taking place. Like example of partial reflection and refraction, say a table which is having a glass top. So if a table is having a glass top, say this is a glass top of a table, and you're looking from here. So what will happen? In this, you're able to see the object which are above the table also, and you're able to see the objects which are under the table as well. So two things happen, refraction and reflection both happen. This is an example of partial reflection and refraction. Yusuf, your question, what does it mean when it refract close to normal? If it refract close to normal, it means speed decreases. If it bend away from the normal, it means speed increases. In this case, moving from water to air, because moving from water to air, the speed will increase. That's why it bent away from the normal. If bent towards the normal, it means the speed will decrease. So partial reflection.
What do you mean by bent towards the normal? What is the normal?
Normal is a perpendicular to surface. Like here you can see.
Yeah, the straight line.
This line which is perpendicular to the surface is called normal. So what happened? The light which is strike, then it has three possibilities. I either go in towards the normal, either go without changing the direction, or either move away from the normal. So what happened? If speed of this is called away from normal. This is called towards the normal. So what happened? When the light moved from water to air, as the speed increases, so it went away from the normal because the speed increases. That we discussed yesterday, that when the speed of the light changes, it went away from the normal. If its speed decreases, it went away. If its speed increases, it will bend towards the normal. This is what happened in refraction. Is it clear?
Yes, sir.
Then what is critical angle? Critical angle, the angle of incidence, the light travel from denser to rarer, it bends away from the normal. The angle of incidence is known as critical angle if angle of refraction is 90 degrees. So when the light travels from high density to low density medium, so it will bend away from the normal. So the light which strike the surface and it will bend away from the normal. So this is a light which is refracted. If I draw the normal, normal is always perpendicular to the surface. So what is the angle of refraction here? Moving from water to air.
90 degrees.
90 degrees. So angle of refraction is 90. So when angle of refraction is 90, the angle of incidence is also known as critical angle. So the angle of incidence for which angle of refraction is 90, this angle of incidence can be any number. Example, if it was 42. So what is the critical angle here? The critical angle is